Hi folks, we're going to take a look at this question from the homework. So they're asking us to find the limit of sine x over the absolute value of x as x approaches 0. Now what makes this problem interesting is that I have to be able to approach 0 from both the left and the right. But this expression is defined differently from the left and from the right because of this absolute value of x. So the first thing I'm going to suggest we do is to rewrite the function sine x over absolute value of x as a piecewise function, which is almost always what we end up doing to solve these problems. Now, if I was finding the limit as x approaches 3, there would be no problem because I could just, since I'm approaching 3, I could just replace absolute value of x by x alone. All right, because I'm approaching a number that's on the positive side. But because it's approaching 0 and it's defined differently on either side, this is why I'm going to first turn it into a piecewise function. All right, so the value at which this changes from positive to negative is 0. So that's why I'm going to split it up as x less than 0 and x greater than 0. Now notice I don't bother with x equals 0 because this expression is not defined at x equals 0, which of course doesn't change the fact that I can still take a limit possibly. All right, so when x is greater than 0, the absolute value has no effect on the that expression inside. So this is just going to be sine x over x. Whereas when x is negative, the absolute value is going to turn it positive. So I can rewrite this as sine x over negative x when the x values are negative. Okay, and the idea being is that we're assuming this x value is negative, so we multiplied by -1 to make it positive. All right, so now when I'm trying to determine this limit, I have to determine it as two one-sided limits. The limit as x approaches 0 from the left, all right, and then I'm going to look at the limit as x approaches 0 from the right. All right, so here, f at x, when I'm approaching from the left, in other words, from negative x values, is going to be given by this function here. So I'm taking the limit as x approaches 0 from the left of sine x over negative x. All right. But if I'm approaching from the right, I'm going to be using this function here. So it's going to be the limit as x approaches 0 from the right of sine x over x. Well, let's deal with the easy one. We already know what this limit is equal to. We know it exists, and we know it's equal to 1. So as I approach this from the right, we're going to be approaching 1. From the left here, well, again, I still want to make use of the fact that I know the limit of sine x over x exists as x approaches 0, but I have this negative in the denominator, so I can just remove it because, of course, it's just essentially just like multiplying by -1, so it's a constant, so I can just remove it from the limit altogether. So I have limit of x approaching 0 from the left of sine x over x, and similar to before, we know that this limit exists and we know what it's equal to. So we have the negative, and then this limit here is equal to 1. And so what we have is that the limit as x approaches 0 from the left is not equal to the limit as x approaches 0 from the right. All right, so this limit does not exist. All right, so recap. Almost any time you see an absolute value in an expression and you're dealing with limits or derivatives, you're going to want to take that function and write it as a piecewise function. Now, like I said, had we been approaching 2 or 3 or -5, I could have just dealt with it in one shot. So if I was taking the limit as x approaches 3, I could just have taken out the absolute values altogether because I'm only dealing with positive values. Okay. Whereas if I was approaching, say, -2, then I would replace absolute value of x by -x because x values are negative and I need to turn them positive. All right. So once we write it as a piecewise function, we can now approach 0 from both the left and the right separately. And in both cases, we made use of the fact that we knew what the limit of sine x over x as x approaches 0 was equal to. Okay, that's it for this one.